Hey everyone, in this video we are going to explore the different types of joins in SQL and see how they work in practice. Why do we even need joins? Well, consider this. In most real world databases, information is not stored in one just massive table. Instead, it's often broken down into multiple smaller and more manageable tables, and each of it focusing on a specific set of data. And the SQL joins allow us to combine the data from two or more tables based on a related column, providing a complete view of our information. For example, imagine you have one table containing product information like product name and another table containing the product category. But what if you want to see a list of all products along with their respective product categories? That's precisely where joins come into picture. Joins will enable us to combine the products table and the categories table using a common related column, such as the category ID in this case. And when we perform a join, the category ID will be matched across both of the tables. This allows the product name to be combined with its corresponding category. For instance, in this table products, the iPhone 15 has a category ID of 4 and the category ID 4 corresponds to mobile in the categories table. So they will be linked like iPhone 15 belongs to mobile category. Similarly, MacBook Pro will be mapped to laptops and AirPods to accessories and Apple Watch to wearables using the category ID column. And all of this data integration is performed in SQL using joins. Now, before we dive deep into the details, remember that joins in SQL are not a one size fits all solution. As you will discover, there are various types of joins available, and the most basic ones are inner join, left join, right join, and full join. We will focus on these four join types in SQL in this video, and I'll call this as the big four basic join types. And in the next couple of videos, we will go through other important join types like self join, natural join, and cross join, which are also important. And then we will explore the advanced joins like left anti join, right anti join, and full anti join. While the basic concept of combining tables is relatively simple to understand, so becoming a proficient in joins depends on understanding which type of join to use in different scenarios to achieve the exact results you need. And remember that all the join types will not give us the same result. So the result of join depends upon the kind of use case that we are working with. And this is very important topic for SQL interviews as well as for your daily work if your job involves SQL. So let's begin with the default and most basic join called inner join. So inner join is the most common and intuitive join, and it will return only the rows where there is a match in both the tables based on the specified join condition. So think of it as finding a common ground between the two datasets. So to proceed further, let's first understand the data that we are working on. Imagine that we have a table called products, which stores information about the items or the products that we sell, and another table called categories, which tells us what category each product belongs to. And the products table has 6 products in this case, and they have the corresponding category ID for those products in the products table. And the categories table has 5 different categories. And if we look at the category ID in the products table, the category IDs are 4, 2, 1, 3, and 7. And in the categories table, the categories are 1 to 5. So from this data, it's very clear that from the products table, the category 7 is not present in the categories table. And the category 5 from the categories table doesn't have any product in the products table. So let's keep this in mind throughout the rest of this video and see how different joins behaves with this kind of data. So to begin with, an inner join. So if we do an inner join between these tables, we get all the columns from the first table and then all the columns from the second table in the result. And our joining key is going to be the category ID, which should be present in both of the tables. So the category ID for the first row in the products table, which is 4 in this case, will be looked upon in the second table. And if there is a match found, then the rows from the first table and the rows from the second table will be merged together, forming a fully joined row that has all the columns from the first table and corresponding matching row in the second table. And then the data looks like this. Then for the second row, a similar lookup will be performed. So the category ID for the second row is 2 and the category ID 2 will be looked upon in the categories table and the matching rows will be placed together at the same level. And similarly for the third and the fourth row where there is a matching category ID 1 and 3. Now, when we are at the fifth row, the category ID in the products table is 7 and is only present in the products table. And this category ID 7 is not present in the categories table. In this case, as this is an inner join, nothing will be done for the fifth row. That is, the fifth row will not be included in the join result. And similarly for the sixth row, as the sixth row is also having a category ID 7, which is not present in the categories table. Now moving to the categories table, the category ID 1, 2, 3 and 4 are already part of the joined rows. And the last row, which is category 5, is not part of the result yet. Because there is no matching entry for category 5 in the products table, the row corresponding to category 5 will not be included in the result. And this is exactly how inner join is going to work in SQL. Only the matching records based on the joining key or joining condition will be part of the joined result. Now let's try to replicate all of this in a real database. Okay, now I am inside this query editor. I'll get some queries here. The first thing is I am going to see if this table products and categories exist first. If they exist, I am going to drop them. So I'll be creating them with the data that we have. Now I'm creating this categories table. So we have three columns in this categories table: category ID, category name, and is active category as well. And I'm creating this products table now. And then I'm inserting some data into the categories table, which is same as what we have seen now, and some data into this products table. And let's look at what data we have. So I'm just doing select star from products, and you can see that we have the product ID 1, 2, 3, 4, 5, 1, 6, and we have corresponding category IDs. So these two columns are going to be the very important one. I mean the product name, which has the name of this product, and the category ID, which we will be using for joining this table with categories table. And let's also look at this categories table. So the categories table has category ID, category name, and there is one more field called is active category. Now let's try to perform an inner join between these two tables. So the basic query to do a join is like we do a select from the table. So this is the first table that we are joining with. And then we do an inner join. And when we do inner join, we provide the table name. So we are joining products table with the categories table, and we are using an inner join between these two tables. I am aliasing the products table as P and aliasing categories table as C. So aliasing is also very important when we are doing joins, because when we are referencing the column names, we can reference the column names in that particular table using this alias P dot category ID and C dot category ID, so that the query will know which column, I mean the column from which table we are referring to. Now I think it's clear. We mentioned the first table and then the second table and joining condition. So in this case, we are using a only one condition, which is category ID match between both of these tables. So when there is a category match, we are telling it to perform an inner join. So let me try to execute this query. So select star. So as you see that our input data has, in products we have 6 records, and in categories we have 5 records. But if you look at this result, it has only 4 records, because the category ID is matching for only 4 records, as we have already seen in this visualization. The category ID 1, 2, 3, 4 has a match in both of these tables. That's why only the rows that are corresponding to the categories 1, 2, 3, 4 are displayed in the result. So this is how an inner join is going to work. You should also make a note that inner join is the default join in SQL or any database. Even if you don't mention this inner join, and if you just mention this join between two tables, and still it will do an inner join and only display the results for the inner join. When we are performing a join, the first table, I mean the table which we are joining with, is called the left table, and this is very important for our upcoming join. And then the second table that we are using to join, I mean we are joining the second table, right? This second table is called right table. So the first table is going to be the left table and the second table is going to be the right table. So see, the columns for the left table will be displayed first and the columns for the right table will be displayed next when we perform a join. One more thing is, here we are doing a select star. When we do a select star, all the columns from all the tables that are part of the join will be displayed. But what if we need only columns from products P and we don't want any columns from categories C, but we want only the columns where there is a match between the category ID. In that case, we can only mention one table. So P is going to be the products table. I'll just mention, instead of providing a star like as in the previous query, we can just mention P dot star, which will display all the columns from the products table and will not display anything from the categories table. So let me just run this. See, this query will basically perform an inner join, but it will display only the columns in the P table, which is the products table. And similarly, we can do it for categories as well. So if we just mention C dot star and run this query, it will display only the data in the categories table where there is a match in the products table, right? So let's say that if someone asks you to write a query to display all the categories where there exists a product in the products table, right? So these are all the categories which has at least one product in the products table, because we already performed an inner join and this is going to be our result. And for selecting all the columns from both of the tables, we can just use star, or we can also extend this query a little bit. So instead of C dot star, we can use both P dot star and C dot star, so that it will select the columns from the both of these tables. I mean, simply we can use star as well. I'm just telling so that you know we can use this way as well. But what we want is, we need the product name and we also need the category name, and we are not worried about any other columns. In that case, we can just mention P dot product name and see that category name in the result and select only those columns, so that only those columns will be included in the result. See, these are the only four products that have a category name in the categories table, and these are the four categories which has an entry in the products table. So this is the basic concept of an inner join. When you perform an inner join, only the common data between two tables will be selected. I mean, this is going to be the common ground, which is an intersection between the two tables, the left table and the right table. And now let's move on to the left join. So okay, before we talk about left join, the next three types of joins, the left join, right join, and full join, are going to be an extension of this inner join. Imagine you want to see all the products, and if they have a category, you want to see that category too. If they don't have a category, you still want to see that products in the result. In that case, left join becomes handy. A left join will return all the rows from the left table, in our case the products table, and the matching rows from the right table. And if there is a no match in the right table, it will put null values for the columns in right table. To simplify it further, I would like to explain this as an extension to the inner join. So these are the two tables that we have started with, the products table and the categories table. The concept of left join is very simple. It's basically the combination of inner join plus all the remaining items from the left table. If you look at the result of an inner join, we know that these four rows are the result of an inner join. And as left join is combination of inner join plus remaining left items, the remaining left items are going to be the products with product ID 5 and 6. So these two items from the left table are not part of the result. So when we perform a left join, these two rows will be brought into this result, which is row 5 and row 6 will be part of the join result. And then you look at the categories table, there is no entry for category ID 7. So what happens to the data in the two other columns which are part of the other table, right? So the remaining columns where there is no entry in the other joined table, which is the right table, it will be replaced with null values. So in this case, for the product ID 5 and 6, the data for the joined result for the columns in the right table will be null. So if you look at the row 5, we have Apple AirTag, category ID 7 and price, and then the category ID in the categories table will be null and the category name also will be null because there is no entry for category ID 7 in the categories table. So this is going to be our result of a left join. So the very important thing is it's a combination of an inner join plus all the remaining columns in the left table, whereas the columns from the right table will be marked as null for the left join result. And now let's go back to our query editor and try to run these queries. For the left join, let's do a selection of product name and category name. So before we do this product name and category name, let's do selection of everything. So select star from products, which is going to be our left table. And again, select, we are doing a join, which is left join with the categories table, which is going to be our right table. So this is going to be our left join query. And when I run this, you see that we have category ID 1, 2, 3, and 4. All of this from the left table, which has some data present in the right table. See, for category ID 1, 2, 3, and 4, we have the data. And if you look at the last two rows, it has the category ID 7. And here, all of this is null. So this is the left join. So left join will basically select all the data from the left table and it will only select the matching data from the right table. And if there is any unmatched data, it will be placing a null entry for the columns that corresponds to the right table. So this is going to be our left join. And in this case, as we don't want all the columns, even if we select only product name and category name, so for the first four products we have the corresponding category name, and for the remaining products we don't have any category name, so it's marked as null. So this is basically the left join. And the very important thing to note is that the first table that we are going to select is going to be the left table, and the other table is going to be the right table. And now let's move to this right joins. So right joins are also very similar to left joins. It is an extension of inner join and the remaining columns from the right table. And to begin with, so these are the two tables that we started with, the products table and categories table. And again, we know the result of an inner join is these four records. Now, if we look at the right table as we are performing the right join, there is one row which is missing in the result, which is category ID 5 and entertainment. So when we do a right join, this will be part of the result. But as there is no entry on the left table, all the rows or columns for the left table will be marked as null. And our final result becomes this. So basically right join will do an inner join plus select all the remaining items from the right table. So let's also try this out in the query editor. Now what I'm doing is I have this products table, which is our left table, and then I have this categories table, which is my right table, and I'm doing a join. Let me select everything, select star. When I run this query, you see that these first four records are matching in both the tables, and the last record has only data For the right table and for the left table columns, everything is marked as null. So this is basically the concept of the right join. So to simplify, the right join will select everything from the right side table and then select only matching records from the left side table. And everything that's unmatched from the left side table, it will be marking as null. So this is all about the right join. Let's try to remove this star and select only the two columns that we need. Even in that case, for the last record, you see there is an entry in the right side table column, which is category name, but the product name is null. So that's how right join is going to work. In my personal experience, we mostly go with left joins. And whenever we want to select all the columns from some table, we make the table as the left table. Basically, all the big tables when we are performing a join will be made as left tables just to simplify and always go with the left joins. But there are many use cases where right joins will also be helpful. We will talk all of this in upcoming videos. And then the next important thing is the full join. We also call it as full outer join. Again, to simplify this, this is also an extension of inner join. So how? So when we do a full join, it will basically perform the inner join and then select all the columns which are left over in the left table and then select all the columns which are left over in the right table. So this is our inner join result, which has 4 rows, and then we have 2 rows left over from the left table, which will also be part of the result, the product ID 516, and the columns in the right table will be marked as null as earlier, and then it will also select the remaining columns from the right table, which is category ID 5 and entertainment, and the columns in the left table will be marked as null. So this is going to be our result when we perform a full join or full outer join. So it will have all the results from the inner join and then all the remaining items from the left table by marking the columns for the right table as null, and then it will also have all the remaining columns from the right table by marking the columns from the left table as null. This is the result of full outer join, and let's try to do this in editor tool as well. So then let's select star, and from products P, category C on category ID equal to product. Category ID in products table equals category ID in the categories table. If I run this, you can see the result, right? So it has all the data from inner join. And now it has the data which is remaining on the right table, right? So it has null for all the entries in the left table. And then it has data for the remaining items from the left table having the null entry for all the columns in the right table. So this is basically the result of full join. And here I mentioned full join. Instead of this, you can also mention the full outer join, which will have a similar impact as the full join. So both are going to be same. And when we select this product name and category name, which are the required fields for us, it will show these number of records, right? So it will have the first 4 records, and then it will have fifth records which is present in the right and not present in the left table, and then the final 2 records which are present in the left table but not present in the right table. So this is basically the full join in SQL. So these 4 joins which we have discussed till now are going to be very basic joins in SQL, and these are also the most frequently used joins in SQL. So understanding the concept of joins and especially these 4 joins is very important, and which will basically lay the foundation for the remaining types of joins that we are going to discuss in the upcoming videos. I have mentioned all the queries to create the tables and insert the data in the video description. You can grab those queries and try it from your end. Thank you. I'll see you in my next video.